Good evening. I'm Kumar Abhishek, and this is a demo lecture regarding the position of tutor in mathematics. And the topic that I'm going to teach is polygons. So let us start with the polygons, with the basic definition of polygon. So polygon is a simple closed curve that is made up of only line segments. So this is the textbook definition of polygon, and we'll see what a polygon is through some examples. So here we have some figures in which there are three figures actually. In these three figures we can find certain characteristics which are like these. They are all are made up of line segments, and these all three are closed, so they qualify as being polygon. The definition of polygon, what we have described, is it is made up of line segments, and it is closed. So in all these three figures we see that they are made up of only line segments and they are closed, so they are polygons. So coming to the next two figures, though these two figures are also made up of line segments, but one of its sides is incomplete, that is they are not closed. So since they are not closed, they do not qualify as being polygons. So this is the basic characteristic in differentiating between any figure as a polygon, or whether a figure is a polygon or not, we can describe it as. So coming to the next characteristic of a polygon that we have is a diagonal. So uh, diagonal is something like a line segment that connects the non-adjacent vertices of a polygon. So let us see with an example that in the simplest of one of the simplest of the polygons we have is a form of rectangle ABCD, in which we define line segment A to C and B to D as diagonal, and these are called diagonals because they connect the two non-consecutive vertices, means the two vertices which are not adjacent to each other. So in this figure we have A and C, so these two vertices are not adjacent to each other, right? So when we draw a line segment from A connecting to C, we get a diagonal. Similarly, when we draw a line segment from B to D, so these two vertices are not adjacent to each other, so these two side line segments are called diagonals for this particular polygon. Similarly, we have another polygon which is a hexagon which has 6 sides. So in this figure you can say from one of its vertices we draw lines to the other sides, the other vertices, and notice that these lines are being drawn to the vertices which are not adjacent, right? So we have drawn to this vertex, we have drawn to this vertex and to this vertex, right? So we are not drawing it to this vertex. In that case it would not be a diagonal. So we have three diagonals from one of the vertices in this particular case of polygon. Also, we have the formula for counting the number of diagonals in any polygon, and the formula is n into n minus 3 by 2. So when we put n is equal to 6, we get 6 into 6 minus 3 upon 2, which is equal to 9, and which states that the hexagon has 9 diagonals. Similarly, if we put n equal to 4, we get 4 into 4 minus 3 upon 2, which is 2. That means a rectangle has 2 diagonals. So in this way we can find the number of diagonals for any number of sides that a polygon may have, right? So coming to the next classification, the different types of polygon that we come across. So the general classification of the polygon is the convex and concave polygon. So in convex polygon we will see with an example again that the all sides, since they are all closed, so these are polygons. This is the basic criteria for any figure to be polygon. And in this particular polygon, all the interior angles are less than 180 degree. So this is the basic criteria for a polygon to be convex polygon. So in this particular polygon ABCD, you can see angle A, angle B, angle C and angle D all are less than 180 degree. Similarly, in this figure also we have all the angles less than 180 degree. Whereas in the case of concave polygon, what we have that one or more than one of the interior angles may be greater than 180 degree. So in these two cases we can see that this particular angle C is greater than 180 degree. In this case also, this angle C is greater than 180 degree. So these two are concave polygons. There is one more criteria, one more layman criteria of identifying a polygon as convex or concave. So suppose we take any 2 points in the interior of the polygon. So suppose we take E and F inside polygon, anywhere inside the polygon, and when we connect these 2 points we get a line segment. And if that particular line segment lies entirely inside the polygon, we call it a convex polygon. So when we join these 2 points, we get a line segment EF, and if it is lying completely inside that particular polygon, which in this case is lying inside the polygon, this EF line is inside the polygon, so this is a convex polygon. Similar in this case also, this is lying entirely inside, right? Again, in this case, we can see that this line segment is passing, a certain part of this line segment is outside this polygon. We have taken 2 points E and F. These points are inside the polygon, and when we connect these points, we got a certain line segment which is outside the polygon. So we will not count them as concave. These are called the convex polygons. So this was the basic definition of convex polygons. And in our course, we will not be dealing with convex polygons. We'll be dealing with only convex polygons in which our line segment will be completely inside. So we'll be dealing only with convex polygons, right? Coming to the regular and irregular polygons, regular polygons are called in which we have all the sides and all the angles are equal. So in regular polygons, one of the basic regular polygons generally we come across square, right? So in a square, what we have, all the sides are equal and all the angles are also equal. So any polygon which have all the sides equal and all the angles equal is regular polygon, right? And on the same side, we have trapezium, in which the one of the pair of the sides are equal. Not all the sides, but one of the pair of the sides are equal. So this is trapezium. Then there we come across a most common polygon, that is parallelogram. So in what we have in a parallelogram is opposite sides are equal and parallel. So what we have seen so far is what polygon is, the definition of polygon, different types of polygons, and we have seen certain common polygons that we come across. So that was all about polygons. Thanks a lot.